So let's just move on further towards the commutative property on our last collection of numbers, that is nothing but rational numbers under addition. So first of all, we'll talk about the rational numbers. They are represented by capital Q, and the collection is nothing but of the form P by Q, such that P and Q both belongs to any integers, but Q cannot be is equal to 0. So this is nothing but the collection of the rational numbers. So under addition, first of all, we'll talk about the commutative property. Let us suppose I will take any rational number out of this particular collection. So let us suppose I'm taking 1 by 2 and 1 by 3. So when I will add 1 by 2 and 1 by 3 in the different order, let us suppose on the first particular example, I'm taking 1 by 2 plus 1 by 3, where 1 by 2 is at the first place and 1 by 3 is at the second place. But now we'll switch the position of both of these as 1 by 3 plus 1 by 2. So the answer will be, so let's just check out the answer. What will be the answer of both of them is 1 by 2 plus 1 by 3. So let if the LCM of 3 and 2 is nothing but 6. We can also do the LCM as 3 and 2. As we know that 3 and 2, or the LCM of 3 and 2 is nothing but 3 ones are 3, 2 ones are 2. So the LCM will be 3 into 2, which is nothing but 6. So hence 1 by 2 plus 1 by 3, for both of them the LCM is 6. The answer will be 3 plus of 2. 3 plus 2 is 5 by 6. So for the second case, 1 by 3 plus 1 by 2, the LCM will be remain the same, that is 6. 1 by 3, so the answer will be 2 plus of 3, and it is nothing but 5 by 6. So at the end, what will be the conclusion? The conclusion for both of these examples is that for any two rational numbers A and B, here A is half and B is 3, whenever I'm adding any two rational number in the different order, means A plus B and B plus A, the answer is always same. Why so? Because when I have added 1 by 2 and 1 by 3 in the different order, both of them are giving the same result as 5 by 6. So hence A plus B is equal to B plus A. It means that addition is commutative in nature. Addition is commutative. Why so? Because A plus B is nothing but is equal to B plus A. So let's just move on further towards subtraction. Let us suppose we'll take another particular rational number. Let us suppose I am taking the rational numbers as 1 by 3 and 1 by 4. So let us suppose 1 by 3 and 1 by 4, we are subtracting both of them in the different orders. So first of all, I'm taking 1 by 3 minus 1 by 4, and in the second case, I'm taking 1 by 4 minus 1 by 3. Means I am switching the position of both of them in the different senses, means A minus B, and in the second time, I am taking it as B minus A. So 1 by 3 minus 1 by 4, let us suppose I'm taking the LCM of 3 and 4. The LCM is nothing but 12. So 4 minus 3 is nothing but 1. So it is 1 divided by 12. So in the second case, 1 by 4 minus 1 by 3, the LCM is nothing but 12. But 4 3s are 12, means 3 will be multiplied with the numerator 1. So 3 1s are 3 minus of 4. The answer is different over here. Why so? 3 minus 4 is nothing but minus 1. So it is minus 1 by 12. So hence, what will be the conclusion over here? The conclusion is that A minus B can never be equal to B minus A. So hence, from this particular example, we can conclude that subtraction is not commutative in nature. Why so? Because A minus B is not equal to B minus A. It means that subtraction is not commutative for the two rational numbers A and B. Here, the first rational number is nothing but 1 by 3 and the second rational number is nothing but 1 by 4. So A minus B can never be equal to B minus A. For the rational numbers, it means that they are not commutative. So let's just move on forward towards hence multiplication. So let us suppose we will take any two particular rational numbers again. So let if I am taking 1 by 2 and 1 by 4. So let us suppose I am taking the example over here as 1 by 2 and 1 by 4, and I am multiplying both of them in the different order. Means first of all 1 by 2 in the first place, and in the second case I am taking 1 by 2 in the second position. So whenever I am multiplying A into B and B into A, the answer will be 1 by 2 into 1 by 4. So 1 into 1 is 1, and the denominator when multiplied with each other, that is 2 into 4. So the answer is nothing but 8. On the same way, 1 into 1 is nothing but 1 and 4 into 2 is nothing but 8. So it means that A into B is equal to B into A. Whenever I am taking any two rational numbers and I am multiplying both of them, then the answer will always be the same whenever you will take them in any particular order. Means A into B or B into A, the answer will always be the same. So hence the conclusion is multiplication is commutative in nature. You can see it from this particular example that A into B is equal to B into A, hence multiplication is commutative. So let's just move on further towards the division. So for the division, let us suppose we are taking further any two examples. So let if I am taking the example as 1 by 2 and 1 by 3. So when I'll divide 1 by 2 and 1 by 3 in the different orders, let us suppose 1 by 3 divided by 1 by 2. So the answer will be, let's just check out the answer. It will be 1 by 2 in the numerator and 1 by 3 in the denominator. So for this case, 1 by 3 is in the numerator and 1 by 2 is in the denominator. So for the first case, the answer will be nothing like 2 will be in the denominator, 3 will be in the numerator. So it will be 3 by 2. And for the second case, 3 will be in the numerator and 2 will be in the denominator. So this is nothing but 2 by 3. So hence what will be the conclusion? The conclusion is that 3 by 2 is not is equal to 2 by 3. From this particular example, it means that A divided by B and B divided by A, they are not equal to each other. So whether or not they are commutative, obviously not they are not commutative. Why so? Because A divided by B can never be equal to B divided by A. It means that division is not commutative in nature. Division is not commutative. Why so? Because from this particular example, what will be the conclusion? A divided by B can never be is equal to B divided by A. So hence the division for the rational numbers under the rational numbers is not commutative in nature. So I hope this whole concept for the rational numbers, for the commutative property under addition, under multiplication, subtraction and division is all clear to you, that why or whether they are commutative under addition, multiplication, subtraction and division or not. And with the help of the counter examples, you can conclude that whether they are commutative or not. So let's just summarize the whole concept of the commutative property under addition, subtraction, multiplication, division for the whole numbers, for the integers, for the rational numbers as this. So let's just start with it. Whether or not the commutative property hold for the whole numbers, for the integers, for the rational numbers under addition, subtraction, multiplication and division. So let's just start with the whole numbers. Whether the commutative property hold for the addition, yes or no? So answer will be yes, as we know from the counter example that we did before, that for any two whole numbers A and B, whenever we'll add them as A plus B, the answer will be same as B plus A. So yes, the whole numbers are commutative under addition. So what about subtraction? Yes or not? So the answer will be no. They are not commutative in nature, because we know that whenever we'll take any any two particular whole numbers, we'll subtract them in the different orders like in A minus B or B minus A, the answer will not be same. So what about the multiplication? Whether they are commutative? Yes, they are commutative. Why so? Because A into B is always is equal to B into A. What about division? The answer is no, obviously. So let's just move on towards the integer under the addition. For the addition, the answer is yes. Why so? Because A plus B is always is equal to B plus A for any two integers A and B. What about the subtraction? Are they equal? No, they are not equal, because A minus B can never be is equal to B minus of A for the integers for the commutative property. Let's just move on towards the multiplication. The answer is yes, they are commutative for the multiplication. What about the division? No, they are not commutative for the division, because A divided by B can never be is equal to B divided by A. So what for the rational numbers under addition? Are they commutative? Yes, they are commutative. What about subtraction? No, they are not commutative for the subtraction. For the multiplication, yes, they are commutative, because A into B is equal to B into A. What about the division? The answer will be no. So this is all about the commutative property for the different operations for the different numbers, that is the whole numbers, integers and rational numbers. I hope the commutative property for all these numbers and for all these operations are all clear to you.